In this example, we see a third algebra machine, but this time it looks like all the blanks need to be filled in. So we're going to have to go down to our final result and work our way backwards to see how this equation was constructed. So what we're going to do is we're going to look at our equation and we're going to ask ourselves, okay, what was the very first thing that happened to the variable w? And I'm going to look right here in the parentheses. Well, the very first thing that happened to the w was that we subtracted 3. So in the first box, I'm going to write subtract 3. That was my first step. Okay, let's come back down here and let's look at what would have happened next. Well, right outside the parentheses, we see that the next thing that happened was that we multiplied by 3. So we're going to have 3 times the quantity, w minus 3. And in here, I'm going to write multiply by 3. Okay, let's come back down here and look at what might have happened next. Well, we subtracted 3, then we multiplied by 3, then it looks like we added 3. So now we have 3 times the quantity w minus 3, close parentheses, and then plus 3. After that, it looks like we divided by 7. So that's going to go in the next empty box. And that's going to give me 3 times the quantity w minus 3, and then a plus 3 all over 7. And then since it's set equal to 3, we output the number 3. Okay, so now we are going to use this list of construction steps and we're going to follow them in reverse order to deconstruct or to solve the equation. And remember, we're going to do inverse operations as we go. So the first one I'm going to take care of is divide by 7, and the inverse operation of that is to multiply by 7. So I'm going to multiply both sides of this equation by 7 or 7 over 1, depending on however you want to think about it. So these 7s will divide out. After the 7s divide out, I'm left with 3 times the quantity w minus 3 plus 3, but now on the right side I have equals 21 because I had to do 7 times 3. Okay, next, working our way backwards, we have add 3, so that means my inverse operation would be to subtract 3. And that's going to leave me with 3 times the quantity w minus 3 equals 18. Alright, after that I see multiply by 3, which means my inverse operation would be to divide by 3. So those 3's will divide out, so I no longer need the parentheses. So now I have w minus 3 equals 6. And then my last step is subtract 3. So my inverse operation is to add 3. And I finish with w equals 9. Now again, I mentioned this earlier that there might be other ways to solve this equation and still get w equals 9. For instance, at this part right here, notice how I subtracted 3. You could have started by the distributive property and you would have distributed 3, but then you would have had to combine like terms. Let's take a look at what that would look like. So I'm going to erase all this. We know that the solution is w equals 9, but I just want you to see how, yes, you can still get the same answer, but I'm hoping you'll get an appreciation for this different way to do it if you start thinking in terms of constructing and deconstructing equations. Okay, so no matter what, we would have to start by multiplying both sides by 7. That's a given. So no matter how I'm going to finish solving this, the first thing I'm going to do is multiply both sides by 7. Okay, so then this is where you have some options. If you distribute the 3, you're going to get 3w minus 9 plus 3 equals 21. And then here is where you have to remember to combine like terms. So I would get 3w minus 6 equals 21. Now, just to be clear, this is often a step where I see students make mistakes. That's a minus 9 plus 3. That means you have a negative 9 plus 3, which leaves you with a minus 6. I often see students writing minus 12 in that spot because they see the 9 plus 3 and they want to add 9 plus 3. But that minus sign means you have a negative 9. So by doing the equation in terms of deconstructing, where you work the operations backwards, it eliminates your chance for error at that point. But let's continue. So at this point, you'd add 6. You'd have 3w equals 27. And then divide both sides by 3. And you still get w equals 9, just like we got last time. It's just a different way to do it. But again, I think there's less room for error when you do the constructing, deconstructing approach. And it also really helps you understand what it means to solve an equation. You're just breaking something down that had already been built. The last piece that was put on to build it, that's the first piece you're going to remove to break it down or to deconstruct until you work your way down to where it began. And in this case, it began with the input number w, which was a placeholder for the value 9.